If you could detect patterns in random chance, control the very essence of luck, what could you do? Impossibly lucky things? Log into lost accounts? Win a jackpot every time? Today, I'll try this. We'll see how computers generate random numbers, learn how to reverse the generators to exploit them, and I don't know, get a few extra jackpots along the way. When your computer is picking a random number, in almost every case, it's actually picking it from a totally predictable sequence. It's just that that sequence is usually billions of numbers long. Good luck remembering that. These sequences come from surprisingly short math formulas that run each time your computer wants a random number. Here's one of the simplest ones. Okay, so you want to log into an old account of yours, but you forgot the password, and when you try to reset the password, it's asking for a 6-digit code that is sent to your old email address, and you don't even have that email anymore. And to make matters worse, it says you only have one attempt left to log in, or otherwise it'll delete your account forever. Oh boy. At first you feel hopeless, but then you find out the 6-digit code is generated by this formula, and that gives you an idea. When I was 14 years old, I found this equation online, just like many others did, and I just wanted something that could generate random numbers. So I yoinked it for my games and didn't think much of it. But is it even good at generating random numbers? Why these specific values? And of course, can we hack it? We'll use the random numbers to generate a picture, and if it looks like pure static noise, then it's good. If we see obvious patterns, then it's bad. We'll start with the number 1 and put it into the input of our equation. So 1 times 9301 plus 49297 modulo 233280. Modulo just means if our number reaches 233280, then we just wrap it back around starting from 0. I like to think about it kind of like the game Asteroids, where when things go off the screen, they appear on the other side again, back at 0. We can make the lowest number black and the highest white, and now we can visualize the random number. To give the gray square a friend, we'll generate the next random number just by feeding the last one back into the formula. Bop boop beep, and this time it surpasses the modulus over 2,000 times. But we'll end up with 127215. Then we just do it again, and again. And there's every number that this generator can make before it repeats. As you can see, there aren't many obvious patterns here, which is pretty impressive. But it doesn't mean that there aren't any patterns at all, because if I choose a different grid size to display the numbers on, you can see some lines forming. But yeah, overall, it's not bad for how simple it is. This type of random number generator is called a linear congruential generator. Congruential, what a weird word. And just to show how important these specific numbers are, if we add just 1 to this first number, look how repetitive it is now. To find numbers that might work well as a generator, we can adhere to the Hall-Dobell theorem's 3 rules. So I wrote code to do just that, and now we have a random number generator. Kinda disappointingly, most have obvious patterns, but when it actually reveals a good one, it feels like I invented something. I love it. I'm naming this one Zanslanz's football formula. Feel free to use it. But yeah, it's good to pick values from the list of proven good ones, which football is definitely not on, but let's stick with it. Actually, let's hack it, create a reverse function so we can completely undo the randomness. Normally, it'd be pretty easy to solve for the previous value. You just subtract the offset and divide by the multiplier. Unfortunately, you just can't do division when there's a modulus in the way. Or can you? You know how division is the opposite of multiplication? Like if x times 2 is y, then y divided by 2 is x. But when you're wrapping numbers around a modulus, sadly, this doesn't work. But it just so happens that when you have a coprime modulus, if you find just the right number to multiply y by here, it's guaranteed to equal x. Like to undo the times 2 here inside of a modulo 5, we can multiply by 3. It's weird, I know, but it's the missing link that allows us to invert our random number generator. In our example, the right number works out to be 179509. This is called the modular multiplicative inverse. So you've just written the inverse random number generator. You can't access your old email address to get the secret 6-digit code to unlock your account, but you can create a new account with an email you do have access to. It sends you a secret code. Quickly, you enter it into your reverse random number generator, and it spits out the previous secret code that the website generated, the one to your original account. Dramatically, you say, "I'm in." But was that a realistic scenario? Maybe. I mean, PHP, a programming language running most websites, has a function called LCG value, which uses a similar number generator to what we just hacked. It's possible a site uses that to generate codes, but it would be very unsafe. A much more common technique for generating random numbers uses XOR-Shift. Let's hack it. There were hundreds of thousands of games made in Flash, and most of them that need random numbers use the built-in random or Math.random functions. And as usual, that makes them susceptible to hacking. Without changing any code and without using a debugger or cheat engine, there are multiple ways to manipulate and exploit Flash's random number generator. Let us look at an XOR-Shift random number generator and see if it's better than the last one we looked at. And also, how do we reverse these things? So XORing and shifting are both concepts meant for the old ones and zeros. So we'll be taking our normal number input and converting it to binary. Instead of zeros and ones though, I'll just display it as black and white squares. Okay, what does this code do? Well, it combines two copies of our input number, but one of them is shifted over by 13 spaces to the left. And the combination of it looks like this. That's the XOR operation, meaning exclusive OR. The output is white only if one or the other inputs are white, but not if both are. It's kind of like if you ever used the difference or invert blending mode in a drawing program, which is always fun to play with. But yeah, that's all this line of code does. Shifts and XORs. So the full algorithm actually does it 2 more times. The next time it shifts the result 17 spaces to the right, and then it does it 1 more time, shifting 5 spaces to the left. And when we plot the results of this random number generator, just like before, we can indeed see that the resulting image looks like random noise. And since computers love working with ones and zeros, this algorithm is typically faster than the linear congruential generator we looked at earlier. So as you can imagine, this algorithm is very popular. But when I first saw this, I was like, it seems hopeless to ever get back the original number after messing everything up with XOR shifts. But as it turns out, XORing is a very reversible process. If you XOR one thing with something else, you can get back the original just by doing it again. Neat. How does that help in our case? Well, let's look at an example where we XOR shift the input to the left by 7 spaces. Notice how these 7 bits were not affected at all by the XOR shift. The rest of them were. So by XOR shifting these 7 bits again, we'll at least get back the original state of 7 more, which means we can now use those 7 to repeat the XOR shift again and again and again until we successfully undone the entire XOR shift. It's totally reversible. Yay! There are 2 equivalent ways of doing this. First is just XOR shifting the final state over by increments of 7. And second is by XOR shifting the previous state twice as far each time. It's all the same. We get back the original value. All right, here's our original number generator, and then here's the inverse function. But that's XOR shift 32. There's 64, 128, star, plus, Zoshiro, Zoroshiro, and so many more. Some of the techniques I showed are used in reversing these random number generators, but each one ends up being its own big puzzle to figure out. JavaScript uses XOR-Shift 128 plus, and it is reversible. Either you can use Z3, a framework where you basically describe the problem with code, and Z3 searches the problem space for a way to solve it. Shout out to Pwn function for demonstrating this brilliantly. Or you can code the inverse by hand, as Scott Contini wrote about a few months ago. Minecraft uses XOR-Shiro 128 plus plus. and there are active efforts to reverse it, but it is apparently a significantly more difficult problem. But what does Flash Player use to generate random numbers? Reversing it could affect speedrunning Flash games or allow us to reveal rare aspects of classic Flash games. Flash uses a linear feedback shift register to randomize a seed number. Then it does a combination of XOR-Shift and subtract shift, and then something sort of like our linear congruential generator, except polynomial. Ooh. And then another XOR-Shift, subtract shift thing. Why not? But with a little effort, each step of this random number generator is reversible. In 2017, Dango wrote the reverse function. In 2019, George DeCelianu wrote a paper optimizing it. A speedrunner named Kung implemented a full working demo, then RandomNo archived the test results. I went to test them out myself, but it sounds like Kung lost the original project files. So I tried decompiling the archived version, but unfortunately, it was only working 50% of the time due to a bug with the decompiler. So I found and reported the bug, and it was quickly fixed. So finally, I am now fully in control over Flash's next random number. So what should it be? Out of all the numbers, what could I possibly have chosen for it to display? It doesn't even matter. You already imagined what I chose. So I'm going to go in and change it to 1, 2, 3, 4 instead. All right. There we go. So my brother has a knack for finding 4-leaf clovers. I've never found one myself, only the boring 3-leaf kind. So just to get a sense of how my brother feels on a typical afternoon, I'll override my luck on a classic game about finding 4-leaf clovers. 7 of them, to be exact. Using the hacked random number generator, I identify a seed that always returns low numbers 7 times in a row. This will force most of the 4-leaf clovers to be at the top of the field. And as a surprise bonus, this also usually results in discovering the same exact seed number every time. Yay! All 7 out of 7! Wait. But all this kind of relies on forcing Flash Player to generate certain random numbers. So in this demo, I will detect and predict random numbers just by observing the game itself. No seed number manipulation or anything. This is the Flash version of Minesweeper, and my goal is to predict all 99 mines in expert mode without manipulating its random number sequence at all. And here's what I did. I created a program that allows me to input the locations of mines in a beginner puzzle. Then my program scours billions of seeds in the search for one that could generate the same exact puzzle. Once it finds one, it predicts the mine locations of the next expert puzzle to generate in Flash. Okay, I've flagged every mine. Let's see if we got it right. Whoa, it actually worked. Obviously, this all just feels like cheating and ruins the game, but at the same time, I feel like a wizard of luck. It's kind of scary. The funny thing is, though, as I was re-implementing the expert mode generator, I found a bug in the source code that means it will only ever generate mines in these locations. I think this exploit is way more useful than being able to just reverse the random number generator. Jeez. So I guess my advice to developers isn't to worry so much about which random number generator to use. I mean, definitely use ones labeled cryptographically secure if you're writing a login system or something. But if you're generating numbers offline on someone's computer, you can pretty much guarantee it's hackable to some degree. I would suggest just being a little bit more concerned about the simple things, like not leaking data between programs, like Flash did, or not coding in exploitable patterns, like the Minesweeper game. And maybe just be a little bit more suspicious of speedruns. Sometimes people can be a bit too lucky. Isn't that right? Me getting 5 jackpots in a row in my spin the wheel game I made when I was 11? Look, I spent hours trying to beat my own high score on Spin the Wheel. I just want to know how it's possible. How did 11-year-old me get so lucky with the score of 1,026? Well, he certainly didn't manipulate Flash's random number generator to win a jackpot. Twice. 3 times, 4 times, 5 times in a row. Obviously the score doesn't count, but it still feels cool to be insanely lucky. On that note, the last game I manipulated was a Flash slot machine, mostly because it looks cool, but it turns out the earliest possible opportunity you have to get all 7s is after 5 pulls. So the random number generator has to carefully coordinate 15 numbers to achieve this final, unreasonably lucky spin. All right, I think that's all out of my system now. I'd only gamble if the odds are under my complete control, as so should you. But I really should try to find a real 4-leaf clover one of these days. That does sound nice.
There's gotta be a clover in here somewhere.
Well, hey, thanks for watching. And if you subscribe, I'll see you next month.